All right, so here we go, chapter 8.2, well, 0.1 really, because we're going to break this into a couple sections here. There we go. Arithmetic sequences. So arithmetic sequences, basically I kind of think of them as, well, it's just arithmetic. You're basically just adding the same thing over and over again. And we're going to go ahead and define that as being D. That is the common difference between any consecutive terms. So that's going to be a key value that we're going to look for pretty much any time we're dealing with arithmetic sequences. Now, adding a pattern, an adding pattern, again, kind of what I was saying. Common difference, D, is simply equal to a to the n minus a to the n minus 1. An example would be a to the 2 minus a to the 1. So it's just consecutive terms subtracting the second term of those consecutive terms from the first one. Okay, and this could be a 2 and a 1, or it could be a 3 and a 2, or 199. It really doesn't matter as long as they're consecutive terms. Okay, so an example would be here. Now, we can obviously see that these are going to be increased by a steady amount, and in fact, they're being increased by 2. We add 2 to each one of these, okay, and we get the next term. So if we want to know D, which again, we're going to find pretty much any time we're dealing with these, we're going to take one term, 4, and then subtract the term that comes right after it, 2. And then we get D. Okay. Another example would be something like this. If you want, you can take a moment to pause the video. But all we're going to do is pick any two terms here, and I'm going to pick the first 2, but you could pick 3 over 2 and 4 over 3. Doesn't matter. And basically, this would be a sub n, and this would be a sub n minus 1. Okay. And we can see here a sub n minus a sub n minus 1. Okay. Get a common denominator, subtract them out, and we find that D is in fact equal to 1/6 in this case. Okay. All right, moving right along, that's going to be important, and basically what that boils down to is it's our slope. If you think about it in terms of a line increases by a steady amount. It would go up 1 and over 6 each time, up 1 over 6, so on and so forth. And now, the reason I mention a line is the way we're actually going to find the nth term, so any term, doesn't matter what it is, we can find simply by saying that a to the n, okay, is going to be equal to D. So that change, and again, if you notice, this looks just like slope-intercept form, that constant change times whatever number we're looking for plus the initial number, and this would be basically our y-intercept. Now, we find the y-intercept by simply taking the first number in the sequence and going backward one of those constant values, that constant difference we have. So we take a1 and then we subtract the difference between all of the numbers in our sequence, and that gives us a sub 0, or basically our initial value. Okay? And we can look at an example here. If we wanted to find the formula for the nth term of this arithmetic sequence, well, first off, we need to remember we're going to find two things. We're going to find D, and we need to find a sub 0. So we'll start with D, since our formula for a sub 0 actually includes D. Okay? And to find D, we can pick any two values. Again, I'm just going to pick the first 2, make it easy. We take the second value of the 2 we picked, 8, and then subtract it from the first one, 5, and we see that the difference between all of the values we have here is going to be 3. Obviously, we have to be confident that it is an arithmetic sequence, so it's not a bad idea to double check that you can do this with a couple different values. Well, now we have D. The only thing we're left to find is a sub 0. Now we find a sub 0 by taking the first term in the sequence, 5, and subtracting D, which we just found. Basically moving backward 1, and we get to 2. So to write out the formula, we're simply going to replace D. Okay? We're going to replace D with what it's equal to. Okay? And we're going to replace a sub 0 with what it's equal to. Okay? And then that gives us the power to find any number in the sequence, or any term in the sequence. So now, for example, if we were given a problem where we were asked to find we had a sub 1 is equal to 3, a sub 2 is equal to 13, and we're asked to find a sub 9, Well, first off, we're always going to find that D is supposed to be equal to, or we need to find D, and we need to find our initial value, A sub 0. So basically our slope and our y-intercept, if we want to think of it in terms of a line. Now we're going to write a formula for A sub n. Okay, first, because that A sub n is going to give us the power to find A sub 9. Okay, and the first thing, as I mentioned before, we're going to find D. We just took the second term and subtracted the term before it, and that gives us a D value of 10. And then we're going to find A sub 0. Now A sub 0, we go to our first value and subtract the difference between all the values, 10, and we see that it is -7. So we would have to go all the way back to -7 if we wanted to start kind of at the origin almost for this one. Okay, so in this case, and again, that kind of makes sense. This is basically on the x-axis, right? That's our input. All right, so then we plug in those values. Okay, we get we put 10 in place of D, and we put 7 or -7 in place of A sub 0, and we have our equation. Well, once we have that formula, well, we can find any term we want. So if we want to find A sub 9, well, we're replacing in with 9, so we just do that in our formula. Okay, and you can see here that instead of an in, I've just replaced it with a 9. Multiply it out, and we find that A sub 9 is simply equal to 83. So as you can see, this is pretty powerful. Once you have a formula, you can find any term you want. And again, this has implications in programming and just different types of software development, among other things. Okay. So writing formulas given two non-consecutive terms. So this is where it gets a little bit tricky, okay, but I'll walk you through it. So the idea would be that we have something here. This equation, okay, basically boils down to, if we kind of work it out here, that we are more or less, and I don't necessarily want to confuse you too much here. We still basically need those two things, D and A sub 0, but since they're non-consecutive terms, we have to be a little more cautious about how we do that. And we're going to kind of manipulate it in a slightly different way. So you will want to go ahead and write down this formula. And in class, we can maybe discuss how we can relate those two formulas together a little bit better. But for now, we'll just stick with the formula here. Okay. So in an example like this, we're given that we want to find A sub n, given that that A sub 1 is equal to -4, and A sub 5 is equal to 16. Okay. So first off, if we go ahead and just say that A sub n is equal to 16, okay, then we can go ahead and find that n is then basically just 5. Okay. And if we say that A sub m is equal to our other term here, -4, well then m would be equal to 1. In which case, all we really need to do now is plug those values into the formula that we were given right here. Okay? So basically, we're just determining that A sub n comes after m, and we're defining these values. Okay? Okay, 5 and 5. Okay, and then we got a 1 here, and that's going to be our 1 there as well. Okay? Okay, so we plug all of that into the formula. Okay, and if you notice here, it's just a plug and chug kind of thing. The 16 is A to the n. Okay, the 5 is our n. The -4 is our A sub m, and the 1 is our m. We plug all of that in, do a little math there, and we get D equals 5. And again, that's our whole goal. We got to find D. Once we know D, well, we already know A sub 1. A sub 1, okay, is just equal to -4. And if we want to find A sub 0, we're just going to subtract 5 from that, because D is our difference, right? So if we want to go from 1, we just subtract how far apart each one of the terms in the sequence is, and we get there. Okay. Now we get that A sub 0 is -9, and we just write out our formula. A sub n is equal to D times n plus A sub 0, we plug in those values that we just found, and we wind up with a sub n is equal to 5n minus 9. Okay. Now, the last piece here, at this point, if you don't want to go over this part, that's perfectly fine. I did want to put this in here just so that you had it if you needed it. But here they say to find the formula for a sub n, given that a sub 1 is equal to 200, and that a of k plus 1 is equal to a of k minus 10. Now, once again, all we're really looking for is we just need d, and we need a sub 0. And again, we use d to find a sub 0. Now, I'm looking at this, and I'm saying, well, to find d, I just need 2 consecutive terms. Well, since I already know this, why don't I just make this a sub k? If I make that a sub k, okay, so if I make this one, or so basically I'm making, this is a sub 1, if I make that a sub k, well then what we end up finding is that a sub k plus 1, or in other words, a sub 2, since in this case we have a k equal to 1, is simply going to be equal to 190. Okay? So if I know that that is the case, I now have 2 separate values that will allow me to find that difference. Okay? And we end up seeing that in this case, the difference is that we are decreasing by 10. And that actually should have been fairly obvious from here. We take whatever value it is and we're going to subtract 10 from it. Okay? And we see that we have 2 terms in the sequence here as well. Okay, so our d is simply going to be equal to 10. Okay. Now we just need to find a sub 0. Well, once again, we're going to take a sub 0 is simply equal to a sub 1, 200, minus our d, which is negative 10. So we get that, in fact, the difference is that each time we go up in the series, we are going to be, or I'm sorry, if we want to go backward in the series, we start at 210, and then we're going to be decreasing. Okay, which is why we see that a sub 1 is 10 less than a sub 0. Then we're just going to write out our formula based off those values. Okay. All right, if you have any questions, please make sure to write them down or shoot me an email. Otherwise, I'll see you in class tomorrow.